guys, welcome to this video, and today we're going to talk about the dependency inversion principle, right? I'm Poliana, I'm a full stack developer, and I also mentor some developers. So let's get started. What is a dependency, right? So let's explain that, right? Let's say we have a class, or it could be a module also, but let's say we have a class called user service, right? And then we have another class called MySQL database, right? And your user service class depends on MySQL database class to connect to the database, to get data from the database, right? These kind of things. When we have this situation, you have a class that depends on another class, right? Or a module that depends on another module, right? Okay, but why is that a problem? This is a problem because when you have this situation, you have a high coupling, right? So you have two classes that are really, really, really interconnected, right? And this is a problem because it's much more difficult to maintain this application, to test this application, and to make changes. Like if you want to change the database, if you're using MySQL and you want to change to Postgres, for example, to Oracle, you would have to change also the user service class, right? And this can become like a really mess when you have this kind of dependency between uh, many classes. When you have to make a change, you would have to change many files, many modules, many classes, right? So this is a problem to maintain, to test also, so much more difficult, and to scale the application. It is also more difficult to replace some implementation, make changes, and etc. So okay, now I understand the problem. I understand what a dependency is, but what the dependency inversion principle tells us. What is the solution for this problem, right? So let's talk about it. So the dependency inversion principle says that you cannot have a high model level dependent on a low model level, right? So both have to depend on abstractions like interfaces or abstract classes, right? This way, your code, your application will become more modular, more flexible, and you will not have like problems with changing the implementation, changing the database, for example, these kind of things. And you finally solve the problem of the high coupling, the dependency of one class with another class, right? I'll show you in the code how to implement this principle. But first, I'm going to explain you the difference between the dependency inversion principle and the dependency injection, right? The dependency inversion principle, I already explained. It's a principle that says that you cannot have a high module level depending on a low module level, right? It both have to depend on abstractions. And what is a dependency injection? The dependency injection is the way we implement the dependency inversion principle. I know it looks difficult, but it's not. Using the dependency inversion principle, we will inject in the class the dependencies that the class need, but using the interface or the abstract class, right? I'll show you and you understand. So let's start. Here we have two files, right? The first one I'm going to show you is a file where we are not using the dependency inversion principle, right? So here we have a class called MySQL database. Okay, we have this function connect that return this, and we have also this user service class, right? And you can see here that we call directly this implementation here. You can see that we call directly this class MySQL database. You can see here that we call directly this class MySQL database, right? We also have here a function called getUsers, and we are just giving console.log here. You have to see here is that directly calling this MySQL database. So this class user service depends on MySQL database class. It really depends. So if I wanted to change my database, for example, and use Postgres, I would have to like create another class called Postgres database, and I would have to change here the user service class too, right? So here it would not be MySQL database, it would be Postgres database. We would have to change user service. This cannot happen. We have to have the power to change the implementation of low-level models like databases without having to change other classes, all right? and other modules. So now I'm going to show you how we use the dependency inversion principle correctly. Let's see. First thing I'm going to show you is now we have an interface, right? Now we have an abstraction. That is what, for who don't know, an interface is like a contract that we said that the database, no, in this situation, the database have to have this uh, function, this connect function. So if we have a class called MySQL database implementation like this, and this class implements this interface, this class has to have all the contracts that is set here in the interface, right? So here, this class MySQL database is implementing this interface. So here we have to have this connect function here implemented, right? So this is important. And you showing you the code, and you see the beauty, the beautiful thing that is the dependency inversion principle. So here we have a class called user database service, right? Same as here, same situation, right? And now what we have? We have a private variable of type database, and in the constructor we are injecting what? In the constructor we have a parameter that is a database that of type database, right? Right. So so here in the constructor we have a parameter that will be an object that implements this database interface, right? And here we are just instantiating. Now we have this get users calling this connect function that comes from here, right? That comes from this database. So let's continue. I'll show you the beauty. Here we have a const called MySQL database that is injected here as MySQL database, and we have this constant called user service MySQL, where we are instantiating a new object here called user database service that comes from here or from this class. We are instantiating an object of this class, passing given as a parameter the MySQL database const that is the MySQL database implementation here. So if you want, see the beauty, now is the beauty. If you want to change the database, you only have to change this, change the parameter, just this. So beautiful. So you see the beauty. We did not change anything in the user database service. Anything. We didn't change anything here. We only had to change uh, here when we want to use it, when we want to implement it. So without changing anything in the user service, we can change the implementation of the database. So here we have this PostgreSQL database class that implements the database interface, and here we have the MySQL database that implements the database interface too. So we did not change anything in the user service class, right? We only have to call the implementation we want to use, just it. So step by step, how do we implement the dependency inversion principle? First thing, create the interface. Okay, create the abstraction that will be an interface or an abstract class. All right. Second thing, of course, create the implementation for the interface. Okay, and third thing, third step, um, we have to inject this dependency like this using the constructor, a setter, or another way. But in this example, we use the constructor here, and as I already said, here we will receive an object of the type database that implements the database interface. Okay, we will receive this database object that will implement this database interface here. All right. Um, and that's it. And the fourth step is, of course, call the implementation the way we do the way we're doing here. We are creating a constant that instantiates here the user service and is giving as parameter this MySQL database. And now we are just giving a console log of this get users method here in the user service class. Okay, I understood, Poliana, but how do we identify that our code, our application is too coupled and we have to decouple this application? When you make a simple difference and this cause an impact in many parts of your system, of your application. Second situation that you can identify that your code when it's too difficult to isolate the tests. Okay, uh, okay, the tests always have to be always should be isolated. Third situation is when you have much code repetition. So these three situations is when you have to like pay attention and say, I think I have to decouple this code, this application, the system. So last question: what patterns help to implement, to apply the dependency inversion principle in practice? I would say that dependency injection, of course, as I said here, the inversion of control too, and the use of like containers to inject the dependency that will facilitate the management of the dependencies. All right. I think that's it. I think I said everything I know about dependency inversion control. Please, if you like this video, if you learned something, leave a comment here below and subscribe to my channel. Love you, and I'll see you in the next episode. Right.